Hi, so welcome to another session. So this is another very important question that is asked in most of the embedded interviews, that is on C. So here the question is simple, that from this given array we need to find out which number has the most number of repetition. So basically this is the question related to data structure and algorithm. So here we will be using swapping, partition, quick sort to find out which element has been repeated most number of time. We are using quickshot here to reduce the time complexity of this solution. So finally, if this kind of array is given, where which is an unsorted unordered array, then we first need to order the array and then find out which is the element that is repeated most of the time. So if I run it, then you can see that this is the array which was given, and finally after sorting, this array is sorted, and from here we can find that maximum repeated number is 4. So this is what we will be doing. So let's start. Okay, before going directly into the solution, let's understand the algorithm of quickshot. So quickshot algorithm is very important from the sense of other languages also. Okay, so what is our final goal? The final goal is to sort this unsorted array. Okay, so this unsorted array after sorting will become somewhat like this. So now the concept in quickshot is very simple. We need to select an element and place it in such place that all the elements before it are smaller. Simple. So if I say here, which is a sorted array, any element if I pick, all the elements towards its left are always sorted, and towards its left is always small, and towards its right is always high or larger. So just remember this small concept in quicksort, that we want to place that element in such a position that all the elements on the left hand side of it is always less, and all the elements right hand side of it is always high. That's it. That means the element is already placed at its correct position. Now let's see how we will do it. Actually an array, so every array will have a start index and an end index. Let's say we consider it as low and we consider it as high. Finish. Now what we will do, we will assign a pivot element. So what is a pivot element? You can say the element which will be positioned at its correct place is called a pivot element. So any element we can pick at pivot, so best way is to pick the last element as pivot. So I will say this 55 is the pivot element. Okay, so this 55 is the pivot element. And now what I want to do is, I simply want to place this 55 to its correct position. So for that what I will do is, I will first check if the first element, now let's write it like 30, 45, 10, 9, 80, 55. Now I will check if the first element, that is 30, is less than 55. If it is less than 55, then I will say swap. So swapping between, so that I will do what I want to swap it in between it. So what I will do, I will swap 30 among itself. So that you can be confused that why I am doing it. So for that, just hold on a few seconds. So just remember, if an element is less than the pivot element, then we do the swapping between it and its previous element. Since there is no previous element, so we are doing swapping with 30 itself. So final array after this will become 30, 45, 10, 9, 80, and 55. Now then again we check with the second element. Yes, it is less than 55. Then what we do, we do a swapping between in these two, right? So it will become 45, 30, 10, 9, 8, and 55. Now since we have done a sorting here, so what we have done is, we have incremented the value, like we have come to now this position. So yes, 10 is less than 55. Similarly, yes, it is less than 55. So what will become 45, sorry, it will become 10, then 30, then 9, then 80, then 55. Similarly, it will come here 9 less than, correct. So it will become 45, 10, 9, 30, 80, 55. And finally it will be compared with 80. So is 80 less than 55? We say no, 80 is not less than 55. Then it is over because no other element is before it. Now 80 is the position which is greater than 55. So what we will do, we will swap the position of 80 and 55. So finally we will have 45, 10, 9, 30, 55 and 80. So 55 is placed at its correct position. Now you see 55 is already positioned, similarly 80 is already positioned. Okay, so now what happened is the last two elements are already placed at its correct location. Correct. So now what I will do is, now I know that this is already done. Now since the pivot has shifted here, so I will take this portion of array and again do the sorting in them. So now what is the array now? 45, 10, 9 and 30. So 55 and 80 is already sorted. So now what I will do, I will select 30 as pivot and compare it with 45. So I see 30, 45 is less than 30. You say yes, it is less than 30. So no sorting. Then I will say if 10 is less than 30, you say yes, 10 is less than 30. Then there is a sorting. So 10, 45, 9, 30. So then we go here. If 9, so after 45 we went to 10. Then now 9 less than 30, yes, 9 is less than 30. Then again swapping, so it will 10, 9, 45 and 30. So always remember this, whenever the element, the selected element, the 10 is less than 30, then the swapping should always happen between the previous and the current element. It is not with the upcoming element, it is always with the previous and current element. So finally it has reached the end of the loop where we are not anymore going to it. So now 45 is here and 30 is here. Finally what we have to do, we have to swap the locations of 30 and 45. So you see now 9, 30, 45. So we already have placed these two also in the correct location. Now we only have left with this, so we send this to again to same loop. So now it will be 10 comma 9 only. So pivot we select as 9. So is 10 less than 9? No, we will not swap it. And finally, since there is two element, only after one iteration this will end, and we will swap the location. So finally it will become 9, 10, 30, 45, 55 and 80. So this is the whole algorithm. So first understand it. The basic, so the basic thing is, we need to compare the largest, the highest element with all the elements, since we consider the highest element as a pivot. And if the highest element, if the pivot is less than the compared number, or I can say compared element, then we do a swap between compare I comma compare I minus 1. So we need to do a swap in between them. Okay, so we need to do a swap. Since the first element is already at 0th position, so I minus 1 is not taken, I minus 0 is taken, and it will be swap in between itself. That's the funda here. And finally, whenever we find any element, we need to swap it with the previous element. Simple. And at the end, whatever is the last element we swap, there we have the location standing, and that element and the pivot will be swapped. So this is a way by which we are placing the element at its correct location, such that all the elements before it is less and after it is high. So now let's go to the coding part. Okay, now we have this question. So we have this array. So for the quick sort algorithm to be implemented, first thing what we need is, we need a swap algorithm. So let's write the algorithms that we need, or we can say the steps that we need. So it will be a swap, and here we will be swapping the array. So finally we will be swapping the values into the array. So we need a pointer for that. Okay, so this will be our swapping algorithm. Then what we need to check the partition, like every individual section in which we need to do the quick sort. So we need to have a function that will do the partition, and it will return the pivot element. Okay, so we have an integer that is to be returned as a pivot element, and we say partition. So in the partition we will send the array. So we will have int a like an array, and then we have need to send the high and low. So then int high, let's say int low comma int high. So we will be sending these two, and finally we will return a value that is the pivot element index value. And finally we have the quick short. So we can say void quick short. So in quick short, what we want to send, we want to send an array, and we want to send the size of that array or length of that array. So, and finally what we need a function to print the array. So we say void print array. So here also we send the array and the size of the array. And finally we need a main function from where everything we will be calling. So we will have a main. So in the main we start return 0. Okay, so first thing we need to define an array. So let's define array as a global variable int a, and the value is this one. So let's copy, put it here. So this is the array. So first thing we write the print function. So in the print function what we want to do, we can just write for int I equals to 0, I less than len, I plus plus. We will be printing the value of the array. Printf space percentage d 1% e of I done. Okay, so we can say printf original array slash n. So we print the original array. We say print array, and here we pass array comma the length of the array. Let's say len. So we calculate the length of the array. Int length equals to size of is a function, size of a divided by size of integer, since it's an integer array. So we get the length. So up to this is done. Then we do the print again the shorted array. So we write shorted array. So we can print the shorted array only after shorting the array. So here also we will call this function as quick short, and in quick short we will pass the array comma length of that array. Okay, and finally print the array quick short. Okay, and one more element, one more function that we need to put is this int max element count. So here if we pass an array, it should return the maximum element, that maximum number of repeated element. Here also we need to pass the length. So finally this max repeated element should be called, and it should return the maximum number of element that is repeated the maximum time. So we write max element, we pass the array a, we pass the length. So this returns the value. So we say printf slash n max number of repeated element is percentage d comma this one. Okay, okay, so our structure is almost ready. So now let's start writing the function one by one. So first simply we need to swap the element. Let's take int temp a temp variable, the easiest way to swap. So we store the value of a, star of a equals to star of b, and star of b equals to temp. Done. So swapping is completed. So whatever is the value of a, we moved into b, and whatever is the value of b, we move into a. So swapping is done. Now let's do the logic for the partition. So as we understand that what we need to do, we need to compare the first element with the pivot element. Okay, so let's say int, we say pivot. So pivot element, which element we are trying to make pivot, that is the highest element we want to make it the pivot, that the high element is always the pivot. And now what we want to do, we want to have a loop that will check the elements, and it will check compare with the pivot. So also we declare one more variable as the pvt, the pivot that will start from 0 initial index, and for int I equals to 0, I less than, so I should go all the way up to the less than the high element, high I plus plus. And finally here what we want to do is, we want if the pivot, if a of I is less than pivot, then we want to do the swap, right? So to do the swap, we need to pass. So first what we need to do, we need to increment. So pivot should be minus, like low minus 1. So whatever is the lowest, sorry, not pivot, let's say, let's give it a name as I, the previous element as a I. So let's say previous equals to low minus 1 to make it more like more logical. So we will increment the previous before doing the swap, and we pass a of priv comma a of I. Okay, so here we just pass ampersand, and here also we pass ampersand. So the previous is whenever it is less, then we change with the previous. So this will happen. Finally what we will be doing is, once it is done, we want to do a swap again, that is the swap between the pivot and the final element. So the swap will happen with the final location of this previous and the pivot element. So we say a of previous comma a of high will be done, and finally we will increment the previous, and we will return the pivot value. So this will be the partition function. Just try to understand that what we are doing in this array, we are taking the highest element as pivot, and the previous is always less than the low because it is compared. So if the first element itself is less than the pivot element, then we increment the previous first, because previous is also 0, 0 minus 1 is minus 1, so it is incremented to 0, and then we are swapping 0, a of 0 and a of 0. So if the previous element is not greater, then we are not incrementing it with the previous one. Whenever it is greater, then only we are incrementing this previous element. Okay, so one step, we what we need to do is, here is this, we need to increment the previous first and then swap it, because previous will be less once less. So whenever we want to swap it, we want to first increment the previous and swap it. Since if it is 0 is minus 1, then it is, we cannot do the swap, right? So that's why we always need to increment the previous before doing the swap. So that is fine, and we return the previous finally in the partition. So this partition function is also done. So now finally the quick short algorithm. So this is simple. So what we can do is we can define int low equals to 0 and high equals to length minus 1. 1 minus length will be high. So if low is less than high, then only we do the quick short. Okay, so what we need to do, we need to say quick short. So now also we need one thing as a partition. So we say party or part. So we need this variable. So part will be returned from the partition function. The partition function will return this value. So here what we pass the array, and we need to pass the low and high. So low comma high comma high. So low and high is passed in the partition function. Finally, we are calling the quick short. So what we are doing, we will be calling the quick short function again, a, and here, okay, fine. We need also low and high. So we say low, comma int high, say int low and high. So we remove this and we just declare int part. So partition will be calculated, and finally what we are doing, so whatever is the partition minus 1 is the low and high is the high. Similarly, we copy it, and here we just reverse it. So there will be low and high minus 1. Okay, okay, sorry, partition plus 1 will be low, because partition if return 0, then partition plus 1 will be low. We want to do that. So here we don't need length anymore. And finally, we want to do the max element count. So for this, we'll just copy this loop. So the entire loop will be iterated. And what we want, how we want to print the return the max element is that we want to keep a note of what is the maximum count and then the maximum element. So when any element crosses over that count, then we want to save the, like tell that this is now the highest element. Okay, so this is the count for the max element return function. So you can see this function. This is the what we are doing. We are putting a0 as maximum and temp as maximum. So here we are just checking whenever the count is increased than the actual count, then we are updating the maximum element and the maximum count for that element. And this is how we are always getting the max element, and finally we are returning it. Okay, so now let's run it and see if we are able to print something. Okay, we have a error here. Okay, it is capital, so we need to put this as capital. We need to pass ampersand. Okay, we don't need ampersand here. And in quick short, okay, in quick short we need to pass the low as 0 and high as len minus 1. Okay, so just put, let me put here slash n. So some issue, shorting doesn't happen properly. So let's see what happened here. So swapping is okay, swiping is okay. Then partition. Okay, I think one mistake I made. It will always start from the low. It should not start from the high. Let's run it. Yeah, so now it is working fine. So we get the maximum number of element as 4, and this is the shorted array that we get. So I hope you understand it. So if not, you can look into this video again. So one mistake that I made here is I started I from low, as we are always passing the value of that we get written from this partition in the quick shot, so it is recursively calling it. So instead of always starting from 0, we need to start from the low one. So I hope this is clear for you guys. Thank you.